Experiment number 8. Atterberg limits. For our objectives, to determine the plastic and liquid limits of a fine-graded soil. Proof for plasticity index using liquid and plastic limits. Intended learning outcomes. The student shall be able to define plastic and liquid limits and their relevance to soil classification. Define plastic and liquid limits and their relevance to soil classification. Classify fine-graded soils. Discussions. The determination of liquid and plastic limit is fundamental in defining the boundaries of soil behavior under varying moisture conditions. According to these, Atterberg limits are widely used for soil classification and for deriving engineering parameters through correlations with strength and consistency, making them essential in geotechnical analysis. Explains that the liquid and plastic limits are directly related to the mechanical behavior of soil, particularly its deformation and flow characteristics under stress. These limits help describe how soil responds as water content changes, which aligns with the image's explanation of transitions between semi-solid, plastic, and liquid states. Furthermore, Atterberg limits are controlled by factors such as mineral composition, particle size, and pore structure, which influence the soil's resistance to external loading. Resources: porcelain dish, oven, bannets, spatula, moisture cans. Procedure: plastic limit test. First, mix it with water until it becomes plastic and moldable. Second, roll a portion until the thread reaches 3.2 millimeters diameter. Next, if it doesn't crumble, knead and repeat. If it crumbles at 3.2 millimeters, collect sample. Next, place in a moisture can, weigh, and oven dry. Fifth, determine the water content and repeat at least 2 more times. Lastly, compute the average water content. For the liquid limit test. First, mix soil with water to form a uniform paste. Second, place the paste at the liquid limit cup and level the surface. Third, cut a groove at the center using a grooving tool. Next, operate the device at 2 blows per second. Next, record the blows required to close the groove over 13 millimeters. Sixth, take a sample, oven dry, and determine the water content. Seventh, repeat at least 2 more times. Lastly, determine the liquid limit LA at 25 blows.
Now for the data and results. This table shows the data and results of the Atterberg limits experiment, which was conducted to determine the consistency and plasticity characteristics of the soil sample. The first part of the table presents the plastic limit test results. 3 moisture cans were used to measure the water content of the soil at its plastic state. The masses of the empty can, moist soil, and dry soil were recorded to compute the mass of soil solids and pore water. Using these values, the water content for each trial was calculated. The computed water content values were 29.94%, 30.61%, and 30.87%. Their average value is 30.47%, which represents the plastic limit or place of the soil. This value indicates the moisture content at which the soil begins to behave plastically. The second part of the table shows the liquid limit test results. 4 trials were conducted using different numbers of blows or drops in the liquid limit device. Similar measurements were taken to calculate the water content for each trial. The relationship between the water content and the number of drops was analyzed, and through interpolation, the liquid limit, or LL, of the soil at 25 blows was determined to be 45.24%. Finally, the plasticity index, or PI, was calculated using the formula PI equals LL minus PL. Substituting the values, the computed plasticity index of 14.74 indicates the range of moisture content where the soil remains plastic and helps classify the engineering behavior of the soil.
Conclusion: the Atterberg limit test was performed to determine the liquid and plastic limit of a fine-graded soil sample. The liquid limit is the plastic water content at which the soil starts to behave as a liquid, while the plastic unit is the moisture content at which a fine-graded soil can no longer be remolded without cracking. The plasticity index was computed using the liquid and plastic limeys. This experiment improved our understanding of soil consistency and the importance of Adlerberg limits in soil classification and geotechnical engineering.